Our engineers have designed a wrench to help them adjust a pinion for a new drive system that we've got. It's got some bevel cuts in it, so they asked that I program it, so let's take a run through IGEMS with it. So we'll go into the 3D-5X module, and it'll be a stainless steel, it's 1/4 inch. We'll be cutting it with a 1440 nozzle. So we'll go up to IGEMS menu and import, and that's the part. Usually when you bring in parts, especially ones that are drawn in SolidWorks, they're going to come in on edge like this. So we'll just go ahead and on our cam tab, we'll use the ground button and pick a surface and lay that down on the table. And right now that's how it would be oriented on the table. If I want, I could rotate it 90 degrees in here if I want to cut it left to right, or I can do that later. So if I wanted to rotate it in here, I can come to the align button and rotate, and we're going to rotate it around the z-axis. So now it'll cut like that on the table. So we have a measure command if we want to check to see how big this part is. So I can right click and choose various snap points. I'll just go with nearest and grab something out here to get an approximate distance, and we'll grab something over here. So we see that this part's about 14 inches long, so don't really have to worry about it falling into the tank, so we don't need any tabs. So first we'll try the auto button and see how that goes. We'll do all the cuts, linear piercing. We'll do tilted piercing since it's 1/4 inch thick. It won't take too long to pierce through. We've got our lead-in length, and then we don't need any tabs on here because of the size of the part, so we'll just zero that out. If we want to cut past where we let in a little bit, we can put a little bit of overcut on there. So it'll go through and find the edges, so the outside cut's a vertical cut, and then on the teeth we've got the angle there, and then you can see how that angle changes. So it starts out at this angle and then changes as it goes along there. Now it's probably not a great position for the lead-in, so we can go ahead and change that. So we'll go into our toolpath area here. We've got our two cuts, which if we want to rename we can. So on the inside cut, if we want to change our lead position, we have to delete the cut. So we'll just go ahead and delete that, and then we'll use our plus button to re-add it. Upper curve will be this, and we'll pierce right there. And then we'll hit enter to go all the way around this, and we'll go in this direction, and we'll grab that for the lower curve. And then for a lead-in, we'll just hit enter when our line snaps in right there. And then for our lead out, if we want to have a little bit of a lead out, we can just hover our mouse out here and left click. So we got 0.18 for our lead in, 0.04 for lead out, give ourselves a little bit more, and then 20th thou over travel. Kerf is on the left. This cut is medium, being that's going to be going on the pinion gear. Let's go ahead and make that a little bit better quality. So I can click here, change that to extra fine, and kerf is on the left, and that's good. We can see the line, so this should be properly sized. So the spacing and the vector boxes here control the length of the different lines that we have here. So the vector line, the vector box controls the length of these blue lines that project up off the surface there. So if those get to be in the way a bit, you can shorten that up. And then the spacing controls the distance of these red lines. So if you wanted to have more of those, then you can change that number also. You'll note since I deleted the original inside cut and then I added it, it now happens after the outside cut, so we want to make sure that we reorder that, and then we'll rename this. And then we can do a simulation by clicking on the green button here. And we can speed it up or slow it down. Okay, that looks good. So we'll go ahead and close out of here. And then right now for our rapids between the cuts, it's going to the top of the z-axis travel. If we want to reduce that, we can click on the rapids button, and we'll just lift 1/2 inch between the cuts. And then finally we should set our 0 point somewhere on the top of the material. Right now it's at the top of the table. So we'll go ahead and click on our 0 point button. So a part like this where you don't have any square corners, that you can place your 0 point, you can right click and down here choose box. And we'll go for this top lower left hand corner here. So that'll put it lower left hand corner at the top of the material. And then we can do a full simulation if we want. So this will show us the inside and the outside cuts. And if that all looks good, then we can go ahead and create part. And if we click on this file name button here, it'll pick up the name of the original file, and then OK. So now we can set our 0 point for the part, and then always click this part button here, and then you'll pick up that proper Z height that we established back in the 3D area. And then we can go ahead and process. So at the beginning of the program, we're going to lift 1 inch, wrap it over, tilt, come down, and pierce. And then between the cuts, right here, we'll lift up 1/2 inch, wrap it over, straighten out, and then come down. So as we're watching this, we're just looking for any erratic head movements that we don't expect. This all looks good so far. We can speed it up. Down here you also have options that you can toggle on and off. Got your little control up here that you can quickly spin around. And that all looks good. So at this point I can go ahead, click on this button here and create my CNC file and give it a try. Any questions, let me know. Thanks.